In the infinite vastness of space, Voyager 1 stands as a testament to the brilliance of human innovation and perseverance. Launched on September 5, 1977, this space probe embarked on a mission that was designed to last just a few years. Its objectives were to explore the outer planets of our solar system, sending back invaluable data and images that would forever change our understanding of the universe. Little did anyone know, Voyager 1's journey would defy all expectations, continuing its exploration far beyond the solar system and into interstellar space. It would provide us with groundbreaking insights into the cosmos, functioning for over 4 decades in a hostile, barren environment. However, in the fall of 2023, after nearly 46 years of service, something unexpected happened. Voyager 1 began transmitting a stream of garbled, incomprehensible data, leaving NASA engineers and scientists scrambling for answers. The transmission of unreadable data marked the beginning of a dramatic and suspenseful chapter in the history of Voyager 1. Despite its distance of over 20 billion kilometers from Earth, NASA had been able to maintain communication with the probe for decades. Its mission had long been considered one of the greatest successes in the history of space exploration. However, when the data from Voyager 1 suddenly became indecipherable, engineers faced a crisis like no other. What was happening to the spacecraft? Why was it sending out cryptic binary codes that could not be interpreted? More importantly, could the probe be saved? These questions haunted the team at NASA's Jet Propulsion Laboratory, where Voyager 1 had been monitored and controlled for years. The initial reaction was one of confusion and disbelief. For months, Voyager 1 continued to send data, but it was entirely meaningless. The engineers knew that the spacecraft's scientific instruments, which were designed to measure particle radiation, magnetic fields, and cosmic rays, were still functioning, but the data they produced was not translating into anything usable. The problem, it seemed, was not with the instruments themselves but with the way the data was being transmitted. The transmission systems, the heart and soul of the spacecraft's communication, had malfunctioned. Engineers, located thousands of miles away at NASA's Mission Control in Pasadena, California, were left with the impossible task of diagnosing a problem with a spacecraft that was so far away that even the simplest of tests would take days to complete. As the days turned into weeks and then into months, the situation grew more dire. The engineers at NASA worked tirelessly to decode the stream of random numbers and symbols coming from Voyager 1. They realized that the probe was essentially transmitting a memory imprint, a snapshot of its internal systems, rather than actual scientific data. This discovery provided a glimmer of hope. It meant that Voyager 1 was still alive, still transmitting, and still capable of functioning. But the real challenge now was figuring out why it was doing so in such a chaotic manner. The data was essentially gibberish, but it was possible that there was a simple explanation for the malfunction that could be fixed. However, that simple explanation was elusive. The enormity of the problem was compounded by the vast distance between Voyager 1 and Earth. A single radio signal from the spacecraft took over 22 hours to travel one way, making it nearly impossible to receive a quick response to any corrective measures. Unlike with more proximate spacecraft, the engineers at NASA could not simply send a command, wait for a response, and make immediate adjustments. Instead, each diagnostic attempt took at least 2 days, and the chances of success were slim. It was a race against time, with the specter of failure hanging over every attempt. Every decision had to be made carefully, as even the smallest mistake could lead to the permanent loss of communication with the probe. Despite the mounting challenges, the engineers remained determined. They began by focusing their attention on one particular part of the spacecraft's communication systems, the Flight Data Subsystem, SDS. This subsystem is responsible for processing and transmitting the scientific data collected by Voyager 1's instruments. The team hypothesized that a malfunction in this system, possibly involving a specific chip or component, was causing the corrupted data. The engineers dug into the inner workings of the SDS, using their extensive knowledge and experience to test every component of the system. But despite their best efforts, they came up with nothing. No answers. No solution. As the months passed, it seemed like the probe was doomed. The hope that had once been a beacon for the team began to dim. Then, in February 2024, a breakthrough came from an unexpected source. A scientist working with NASA's Deep Space Network, which monitors and maintains communication with far-flung spacecraft, noticed something peculiar. The data, although incomprehensible, appeared to be a direct transmission of Voyager 1's memory and regulation system. This insight was a game-changer. It meant that Voyager 1 was still functioning and alive, but its method of transmitting data was broken. The team realized that the issue was not with the spacecraft's scientific instruments, but with how it was processing and sending the information back to Earth. They were now closer than ever to solving the mystery. With this new understanding, the engineers at NASA decided to try an unconventional approach. They would attempt to redirect the malfunctioning code to a different section of the flight data subsystem, in hopes that this would allow the probe to resume sending intelligible data. The risk was high. If the new strategy didn't work, the spacecraft could fall silent forever. However, given the dire situation, this was one of the few remaining options available. The engineers knew they had to act quickly, and the timing of each step would be critical. Every signal sent to Voyager 1 had to be perfectly coordinated, ensuring that the instructions did not cause further damage. On April 20, 2024, after months of uncertainty and frustration, the impossible happened. Voyager 1 began transmitting intelligible data again. The team at NASA, who had been working tirelessly day and night, celebrated the incredible success. The spacecraft, which had been considered lost just weeks earlier, was now back online. The jubilation was palpable, and the sense of relief was overwhelming. Not only was Voyager 1 transmitting readable data, but all 4 of its scientific instruments were once again fully operational. These instruments, designed to measure plasma waves, cosmic rays, and magnetic fields, are crucial for understanding the nature of interstellar space. The fact that they were all working again was a moment of triumph for the entire team. This restoration of communication with Voyager 1 was not just a technical success, it was a triumph of human ingenuity and determination. The engineers and scientists who had spent years working on this mission had faced one of the greatest challenges in space exploration, and they had overcome it. The success also marked the second time in just a few years that Voyager 1 had been restored to full functionality after a technical setback. In the early 2020s, Voyager 1 had experienced another problem, one that threatened its ability to continue sending data. But thanks to the tireless work of NASA's engineers, the probe had been revived then as well. Now, after almost 5 decades of service, Voyager 1 was once again providing data from the farthest reaches of space. As Voyager 1 continues its journey through interstellar space, its mission remains as important as ever. The probe has already provided us with critical data about the outer planets, the Kuiper Belt, and the boundary regions of our solar system. Now, it is venturing deeper into the unknown, probing the mysteries of interstellar space itself. The scientific goals of the Voyager mission remain focused on measurements of cosmic radiation, magnetic fields, and particle densities. These data will help scientists better understand the structure and composition of the universe beyond the protection of the heliosphere, the bubble of particles and magnetic fields that the Sun produces. It is a region that no spacecraft has ever explored before, and the insights that Voyager 1 provides will be invaluable to astrophysics. Among the most intriguing phenomena that Voyager 1 is currently studying are plasma waves. These waves are believed to carry information about the density and movement of the interstellar medium, the vast, largely unexplored space between the stars. By measuring these waves, Voyager 1 is helping scientists to better understand the universe beyond our solar system. This is a region that has long been a mystery to astronomers, and the data that Voyager 1 is sending back will help to fill in the gaps in our knowledge. The probe's ability to measure these plasma waves could even offer clues to the fundamental properties of space itself. As Voyager 1 continues its journey into deeper and deeper interstellar space, the mission is providing us with unprecedented insights into the nature of the cosmos. The probe is exploring a region of space that we have only theorized about, and its data is challenging our assumptions and expanding our understanding of the universe. It's possible that Voyager 1 will even encounter previously unknown objects, exotic forms of matter, or signs of extraterrestrial technology. While such discoveries remain speculative, they illustrate the incredible potential of the Voyager mission. There's still so much we don't know about the universe, and Voyager 1 is helping to reveal some of its most profound secrets. Voyager 1's mission is far from over. Despite the many challenges it has faced, the probe continues to send valuable data back to Earth. Experts believe that the spacecraft could continue transmitting data for another 10 years or more, as long as its power source holds out. The probe's batteries will eventually fail, most likely in the mid-2030s, but until then, Voyager 1 will continue to explore the depths of interstellar space. Even after communication ceases, however, Voyager 1 will continue to travel through space, carrying with it the Golden Record, an album that contains sounds and images from Earth, designed as a message to any potential extraterrestrial civilizations it may encounter. Voyager 1's journey through the cosmos is a testament to the enduring spirit of human exploration and discovery. It has traveled farther than any other human-made object in history, and its legacy will continue to inspire future generations of scientists, engineers, and explorers. The data it has sent back has changed our understanding of the solar system, the Milky Way, and the universe itself. And as the probe drifts farther and farther from Earth, its message, both scientific and symbolic, will continue to echo through the cosmos for generations to come.